morning, and welcome to the 10th Annual Green Energy Doors Open event for 2020. This year, proudly held in partnership with the Ontario Centres of Excellence and supported by Enbridge. OSEA's role is building capacity through education and projects that further our understanding of climate change resilience, including sustainable finance, promoting green exports and job creation, growing the bioeconomy in the North, and building sustainable communities, including in our First Nations across Ontario. OSEA also supports regulatory innovation on such issues as distributed energy resources and advocates for its members to the provincial regulator, the Ontario Energy Board. OSEA is a member-based, not-for-profit association governed by a strong board of directors and whose highly motivated interns I wanted to acknowledge as well today. While OSEA has a proud legacy of advocacy for the green energy revolution that has occurred here in Ontario over the past 20 years, OSEA's crown jewel, in my opinion, has always been the Green Energy Doors Open campaign, which provides an opportunity to showcase the best in Ontario's R&D, startups, and mature industry leaders that have invested in clean technology, like Enbridge, in our transition to a low-carbon economy. Our province leads in technological innovation, and I really think we will find our solutions here to climate change. Of course, having enabling policy frameworks, including pricing carbon, along with supporting legislation, leads to accelerate change. Jurisdictions like New York and California lead on North America with incentives for solar storage, and in New York for geo-exchange. OSEA and OCE decided the best way to showcase a wide variety of technologies in Ontario was to arrange them by cluster or groups. The incredible variation in technologies and innovation range from companies like Li-Cycle, which is attempting to find secondary markets for lithium-ion batteries, to Sulfichar, which is a zero-waste hydrogen cleaning technology, turning waste into a rich biochar fertilizer. Together, Ontario's innovators have the potential to solve global problems associated with our climate, waste, and water. Today's GEDO event is virtual due to COVID-19 and would not have developed as you see the program today without the collaborative partnership that quickly was found between OCE and OSEA. To the OCE team, my deepest gratitude. So just a few quick notes on this webinar. Due to tight time constraints, we will not be able to entertain any questions. However, if you do have any questions, please remit them to us via the chat function, and we will endeavor to post answers to them as soon as we can. OSEA and OCE will also produce a recording of the entire event, which shall be posted to our site, along with speaker presentations. Please enjoy the webinar, watch for future OSEA events, and consider joining OSEA if you're not already a corporate member. I now turn the mic over to my esteemed colleague at OCE, Belinda Ray.
Thank you very much, Dan, and good morning, everyone. It's a pleasure for OCE to be supporting this year's OSEA Green Energy Doors Open event in this virtual format. OCE's vision is prosperity from innovation, and it supports the commercialization of academic intellectual property, industry academic collaborations, and the development and adoption of emerging technologies. Through OCE's pan-provincial collaboration platform, we leverage a robust innovation ecosystem to help Ontario SMEs and entrepreneurs build and scale their businesses. And our programs also support the development and retention of talent to support industry right here in Ontario. Today, you will hear from companies who are developing and demonstrating innovative, sustainable energy solutions and driving economic impact in the province. Many of these technologies have resulted from strategic collaborations and partnerships, and these province-wide success stories will showcase how companies in each of these clusters are assisting Ontario in achieving a low carbon footprint in our commercial buildings, industrial plants, homes, and in our mobility solutions. We're looking forward to an engaging session today. Now I'll turn it back to Dan to introduce our keynote speaker. Thank you.
Thanks, Belinda. So the first cluster is waste to energy and waste recycling, and the following companies will present in order: Storm Fisher, Pyrowave, Aqua, Enbridge, and Li-Cycle.
Hi, everybody. My name is Fiona Oliver Glassford, and I'm the Manager of Energy Transition Planning at Enbridge Gas. Firstly, I'd like to congratulate Ontario Sustainable Energy Association, working in partnership with the Ontario Centres for Excellence, for their leadership in bringing about the 2020 Green Energy Doors Open event. Enbridge Gas is proudly sponsoring this Green Energy Doors Open event and has a rockstar lineup of options and initiatives in place to advance the collective energy transition ambitions of our company, our 3.8 million customers, and the province. Bear with me as I have some fun and play this out for you. Energy efficiency and conservation programs. This is the key part of our low carbon work and is like the Rolling Stones of the lineup. Energy efficiency has been around for decades, has a broad range of fans, also known as customers, and a proven track record of hits. In fact, our programs, in collaboration with the market, have saved our customers 30 billion lifetime M-cubes of natural gas and 56.2 million tons of greenhouse gas emissions, the equivalent of taking just over 12 million cars off the road for a year. And like Keith Richards, energy efficiency is still going strong. Renewable natural gas, an exciting part of our low carbon work that now has tangible programs and offerings in place, including projects with municipalities to take waste streams from landfills and turn them into a biofuel that can be injected back into the natural gas system, as well as a voluntary program offering for residential customers where they can choose to green a portion of their natural gas use for $2 a month. Renewable natural gas can be compared to artists like Lizzo, Billie Eilish, or Khalid, who have burst onto the scene in recent years, and now everyone knows their names. Hydrogen, this exciting new option for both electric and gas systems, could one day be the Drake of the energy world, breaking all kinds of records. Just like Drake, who's multifaceted, actor, businessman, as well as musician, hydrogen has potential in many areas. It has the flexibility to tie gas and electric systems together, provide storage and grid balancing for electricity systems. It can blend with natural gas in existing pipelines up to a certain percentages and can be used as a pure substance to power hydrogen vehicles. Currently, Enbridge Gas is eagerly awaiting a decision by the Ontario Energy Board to blend up to 2% by volume in a specific area of our system with hydrogen. Flexible uses and measurable GHG reductions, that's at least partially as cool as Ontario's own Drizzy, right? Enbridge Gas also supports research and demonstration of technologies and solutions in collaboration with market players. Our research and pilot projects are like emerging artists. Insert your newest favorite musician here, in that they often work via collaborations and tackle different components of learning and development towards an energy transition. We also contribute roughly $1 billion to the federal government from the Federal Carbon Charge Program that gets recycled back into the market towards sustainability research and projects. Importantly, Enbridge Gas has a unique opportunity, if adequately unleashed, to provide meaningful change towards GHG targets. The company will do this by safely and reliably delivering affordable energy for Ontarians like it always has done, all the while supporting and advancing newer lower carbon solutions through their adoption curves to commercialization in tandem with other market players. In this way, we all win and get to listen to really great sustainable music and also have a sustainable environment for years to come. Thank you. And now for your Cluster 1 presentations on waste to energy and waste recycling, just like Dan mentioned. Enjoy.
thank you. My name is Brandon Moffat. I'm with Stormfisher, based here in Ontario. And that was a brief video of our anaerobic digestion facility in London, Ontario. We take in 100,000 tons a year of organic waste from restaurants, grocery stores, and food processors and municipalities. Next slide, please. And we convert that food waste into to biogas, which is methane. And that methane, we either turn it into renewable electricity that we sell to the grid, or we turn it into renewable natural gas in partnership with Enbridge, and we inject that into the pipeline. We've been around since around 2006, and we are developers and operators of what I'd say low carbon infrastructure, and are technology agnostic in how we approach these types of projects. So we've also been the founders of Green Mantra, which a lot of you will be familiar with, turning recycled plastics into waxes and fuels, and more recently have started to look at the renewable hydrogen and power to gas space. We have over 10 years of operating experience across 7 different facilities, a team of over 30 engineers, sales, finance, operators, and have grown here in Ontario. And have been pulled around North America and now getting pulled around the world in terms of our technology agnostic approach to how we put these projects together and provide them in a financeable nature, which is an example of that is we have a relationship with Generate Capital out of San Francisco, which is $1 billion sustainable infrastructure company, and they provide us capital to be able to build this infrastructure wherever we go. Next slide. The difference with us is we look to unlock the value of waste. So we look at it and say, all right, what is the highest and best use? And we look to say, how can we build that infrastructure? And now we come at it very much from an operational perspective, rather than just a development. We know what it takes to have this stuff operate and be done in a robust, durable nature. And we try to work with other entrepreneurs and companies and to see them grow. So later on, you'll hear more about Char. They are a tenant on our property, and we provide them with feedstock and support the growth of them. And there's others that you'll hear on the panel today that we do similar things to support the evolution of the sustainable energy space. Next slide. Like I mentioned earlier, plant in London takes over 100,000 tons a year, and we are expanding the facility and adding a 3rd digester, which will allow us to support the Ministry of Environment and the rest of the province in their organics diversion framework. And will produce not only renewable electricity, but also renewable natural gas. And we'll also make a organic-based fertilizer that we'll sell to farmers and horticulture groups around Ontario, as well as to export. Next slide. A new area for us is we're in the midst of construction right now, even during the COVID times. It'll come online at the end of November, and it's in Drumbo, Ontario, so in Oxford County, where we'll take in 100,000 tons a year of municipal organics and separate the inorganics, so the forks, knives, plastic, and such, and turn it into an organic slurry or cake that then can be digested either in London or other third-party digesters such as wastewater treatment plants, Stratford, Hamilton, and the like, as well as farm digesters that may be looking for off-farm organics to support their biogas production. So this is an artist rendering of the facility, but it is very much in construction and looking forward to starting up in late November, early December. Next slide. We've also used our experience in development and operation of this infrastructure. When we looked at the renewable natural gas space, we saw biogas from organic waste and agricultural waste as being one component, but we think the renewable hydrogen, which Enbridge talked about earlier, and you'll hear more about a little later, and also the production of other products such as methane, methanol, and the like, really has something that can be done here in Ontario. So we've completed an initial feasibility study of a 25 megawatt facility and have been looking at where we can do 100 megawatt facilities here in Ontario as well as around North America. We don't see it as a technology issue. It's just a policy and commercial business case issue. And we're actively working in this space. Next slide. Thank you.
Good morning. My name is Jocelyn Doucet. I'm the CEO and founder of PowerWave. Next slide. We're a plastic recycling technology company. So as many of you know, we talk about plastic waste being an issue, and this is really becoming a top headline issue right now. And this is because it's motivated by the fact that we don't recycle much of the plastic. About 12% of what we consume is actually being recycled. and that's mainly through mechanical recycling. So what we're proposing here is a new type of recycling technology called chemical recycling based on depolymerization. On the next slide, we see what's the principle behind that. So for maybe 60, 75 years, we've focused on polymerizing materials. So we take monomer blocks and we attach them together to make polymer chains. So the type of bricks can be different, and that means you make different types of polymer chains. So if you have terephthalic acid as a monomer, you make polyethylene terephthalate. If you have styrene monomer, you make polystyrene. So the focus of depolymerization is to really recover the bricks, the individual bricks, by desnapping them gently so you don't damage them too much. And by not damaging them too much, then you preserve the value and you preserve the functionality of the monomer. You have different types of technologies that can do that, as we can see on the next slide, where you can either do some dissolution technology like purification, where you keep the polymer chain intact, or you can do a decomposition type of reaction like what we do, where we essentially break down the polymer chain back to the monomer structure. And you can go a little bit further up in the chain where you do some conversion technologies, where you go either up to the naphtha range or up to the olefin range. And that takes more energy to return back into the loop, but still you're able to recover full value and full functionality of the monomer. On the next slide, we see what we do specifically at PowerWave with polystyrene. So we're able to use our unique microwave technology to disconnect the bricks without damaging them too much. And we're able to return back to styrene monomer, which has a tremendous amount of market use, back into polystyrene for sure, but also in a various range of other styrenics like styrene butadiene rubber, which is found in tires, acrylonitrile butadiene styrene, like what you have in electronics, and many more. On the next slide, we see precisely what our technology platform looks like. So we've been 10 years in the making, developing this technology from lab to commercial scale. We're initiating our commercialization phase right now in Europe and Asia. Our technology is 100% electrical. That's a main differentiator, because now we're able to use renewable energy to close that loop. And because of the microwave action, which is really the core of our IP, we have the highest yield of monomer, meaning that when you're desnapping the bricks, then you don't damage them as much as other technologies. And so you're able to recover a lot of good quality bricks or monomer to flip back into the loop. Because of that energy intensity, we're much more compact. So the microwave power allows you to have a much bigger energy density, which makes it much compact. So it's very, very important when it comes to rolling out this technology to not maximize or to minimize the footprint that the technology requires on the ground. And basically, you have also a higher tolerance to contaminants because it's a thermal process. So other chemical-based or purification processes are usually more sensitive to contaminants. And in the plastic waste world, contamination is always present. On the next slide, we see what the environmental gain is. And specifically for Ontario, that was a major interest because there are producers of styrene in Ontario. And so therefore, if you're able to offset production of virgin styrene by using closed loop monomer, then you're able to save a tremendous amount of energy and greenhouse gas emissions. And that's basically because the production of monomer relies on pretty old technologies where it's mainly thermal based. So you're burning energy to make steam and power the process, which is why you need 60 gigajoule per ton only to make that monomer from crude oil or gas, whereby when you keep that structure intact by gently breaking the bricks apart, then you're able to significantly reduce that amount of energy needed. Finally, there are a couple of challenges in the chemical recycling world that we see on the next slide, where we do struggle finding the feedstock. Although there's feedstock everywhere, it's very difficult to funnel it into these technologies. So there are infrastructure needed. There's definitely a push for policies that will enforce minimum low carbon or recycled polymers in your products. We need to harmonize the definitions of different chemical recycling technologies, and we need to communicate wisely on how we can do this this transition to chemical recycling. So PowerWave is kind of at the beginning of the commercialization phase, so we've been supported by OCE early on, and because of that strategic fit with the Sarnia cluster, and we believe that we will bring significant value to our Canadian ecosystem, but also internationally, because this is a broad issue that is shared among different countries and different continents. So thank you for listening.
Morning, everyone. This is Indra Maharjan from Ontario Clean Water Agency. Aqua is a Crown agency under Ministry of Environment, Conservation and Parks. So it's a very interesting experience for me as a public agency to be among all the innovative technology providers. We are the largest water wastewater operators in the province of Ontario and potentially Canada. We were rated in the top 5% out of 400 utilities in North America. We have about 700 staff, operations mostly, and our core service area is operations. But it's been 25 years we have been operating most of the water wastewater systems for about 200 municipal clients in Ontario, and we now try to leverage other knowledge we have gathered for these services. So traditionally, wastewater treatment plants has been functioning. Next slide, please. So these are the additional services we provide in addition to water wastewater operations. As you can see, building on all the energy, biosolids, and other services, we started exploring and trying to transition traditional water wastewater operations from treatment philosophy to resource recovery philosophy, and that's where we headed. So we started energy conservation and energy efficiency for last 5-6 years, and now we are embarking on energy recovery aspects of those opportunities. Next slide. So what we have been trying to do is, as I said, traditionally, wastewater comes into the treatment plant, and the primary function of these treatment plants is to treat these wastewater and generate the output, clean water, and discharge into environment, and then manage the sludge. If the plant is anaerobic digester plants, they also produce biogas, and flare the biogas into environment. What we are trying to do in Ontario is we are trying to shift this overall philosophy of treatment to meet the compliance to a resource recovery. So you have a treated clean water, and is there opportunity to reuse that water? That's one angle we are looking. Second, the central theme we are looking is sludge. So biogas, instead of flaring the biogas, and as you know, methane has more potential of greenhouse gas emission than carbon dioxide. So instead of flaring that biogas, can we convert it to clean fuel such as renewable natural gas or hydrogen? And then biosolids. Most of the biosolids is land applied, and with the climatic change and availability of the land, those resources are being limited. So can we upgrade these biosolids into upgraded fertilizer for a beneficial uses of biogas? And the last resources we're trying to recover is phosphorus. As you know, based on which area the plant is located, there's some strong requirements around the discharge of phosphorus. So phosphorus is one of the area that we are trying to recover. So ultimately, we're trying to shift this philosophy from let's treat this wastewater and just discharge into environment, but rather than let's use this facility and leverage the existing facility to support the government programs such as waste diversion. And who would have imagined that during the COVID, this file will be so busy? As you know, currently in the province of Ontario, the food and organics framework is up for consultation. Recycle programs are up for consultation. So a lot of activities happening, and we are trying to support the government to meet those objectives. Next slide. The additional key drivers, there's about 68 anaerobic digester wastewater treatment plants in Ontario. We work with the stakeholders to do a study to assess the capacity of these plants. And most of these plants are around 60 to 70% capacity. So there's a free capacity available, and with the adoption of innovative technology, the throughput and the efficiency of the plant can be increased, freeing up more capacity. Most of the landfills that the municipalities own are almost to the end of their life cycle. And as we all know, creating a new landfill is almost impossible. A lot of these municipalities are, even though the regulation doesn't require them from the environmental concerns, they are trying to come up with the green bin programs and innovations, promoting innovation. There's fundings available. OSHI is one of our key partner who has funded the Stratford project. And then the other objectives are greenhouse gas reduction and clean fuel generation. So there's multiple benefits and key drivers for these co-digestion projects. Next slide, please. So what we are trying to do, so we are basically trying to take an existing wastewater treatment facility and retrofit the digester they have that with some innovative technology that will make more capacity available in terms of throughput, bring in the additional organics, food waste into the plant, whether it's a pre-processed or a raw organics, and increase the volume and rate of the biogas that's being produced currently, and upgrade it into either renewable natural gas or hydrogen, whichever is opportunities available. So we are doing a Stratford project, and we have been fortunate for the grant available from OCE. Enbridge as a very true partner around the RNG file. This is the first co-digesters project potentially in Canada, definitely in Ontario. We finally received the environmental permits in June to proceed with the construction. Construction has been delayed by COVID a little bit. 30% design engineering has been completed. RNG offtake agreement is ready to be signed. This project is aimed to divert 21,000 tons of organics from the landfill and resulting in 49,000 tons carbon dioxide equivalent of greenhouse gas reduction, and biogas production increased by about 4%. Now, we are not trying to promote this as the sole option for organics diversion and waste to energy. What we are trying to say is that the municipalities have these facilities. They have spent a lot of money, and these facilities are currently being funded through the ratepayers, the taxes we pay. What we are trying to move is this philosophy of let's convert it from the cost center to a revenue neutral, and also achieve all these other goals and leverage the existing facility. As you can see, the environmental approval took about 16 months. So the other option you can do to manage the organics and produce the energy is to build a brand new facility. And including the zoning and permitting and other environmental approvals, you are looking at about 7 to 10 years for that project to be done. In our case, we are looking around 3 to 5 years. So we're proposing this as one of the good options to manage and achieve the same goals of organics diversion from landfill, greenhouse gas reduction, innovative technology. And we are just helping to develop these projects. We are working with private partners in this project. So in Stratford, Suez is our private partner. GSD is our design build consultant, and Ministry of Environment, Enbridge, OC are all our partners in this project. So learning from this project, we have already identified working on other projects, which is on the next slide. So right now we are also working on other different projects around the similar scope, but little bit of variance around utilization of biogas and a tonnage of organics we can accept, namely town of Petawawa, city of Belleville, Espanola, city of Cornwall, and township of Georgian Bluffs. As you can imagine, the spread of geographic location of these plants also give option to local regional organics management concept. And as I said, we are working with private vendors. So, and as a public agency, our goal is to highlight the objectives and the benefits of the co-digestion approach, and provide it as an option to meet the government requirement around organics management and organics diversion, greenhouse gas reduction, meet climate change goals, and also convert the facility from treatment to a resource recovery facility, achieving net zero energy in near future. Thank you.
This is our home. This is also our home. So, what are we going to do about it? Well, we're told to recycle, throw our garbage in the trash, and ride our bikes to work. But what if I told you that we can turn our waste into fuel? You see, organic waste eventually decomposes and turns into methane. And we know this from grade 5 science class. So, why do we care? Well, what if that methane could be captured, cleaned, and used for energy? Now, it can. It's called RNG, or renewable natural gas, and it can help reduce your impact on the environment by diverting garbage from landfills and turning it into a fuel source. Visit our website to learn more about RNG, because sometimes a small change can make a big difference.
Good morning, everyone. My name is Justin Egan. I'm RNG specialist with Enbridge. I'm happy to be here. Next slide. For a while, for many years, Enbridge has focused on renewable energy development. This all comes down from leadership. We realize that if we're going to stay relevant for the long term, utilizing our assets in a low carbon economy is going to be crucial. Next slide. The market potential from a Canadian perspective is huge. From a study done at CGA, they quoted that approximately 1,200 BCF could be generated in Canada. This represents about 36% of Canada's 2017 methane consumption. This is driven by several different policies. You have Ontario's 2020 food and waste policy, you have federal carbon tax, you have the federal clean fuel standards, as well as several other policies across Canada. Next slide. This wouldn't be possible for Enbridge without a few OEB decisions in the recent years. So several years ago, we received approval for the RNG enabling program. This enabled Enbridge as a utility to invest into renewables. Also very recently, as Fiona mentioned, we received approval for the voluntary RNG program. This will enable us to procure RNG and then sell to our customers on a voluntary basis. Next slide. A few different projects that you may have seen recently in the news. We've been working with Toronto lately with their municipal digesters to produce renewable natural gas. We've also very recently, you may have seen a Niagara project. We're working at a landfill in the Niagara region to produce renewable natural gas. It was mentioned earlier about our project in London as well. Very excited about that. And we've been working for several years at a wastewater treatment plant in Hamilton. So you can see we've touched on a few different sectors here: ADs, landfills, wastewater treatment plants. Currently, we're dealing with several other municipalities. We're dealing with several other farmers, lots of other municipal or merchant digesters. And we're looking for ways that we can partner with valued sectors to produce renewable natural gas, to reduce emissions and to meet climate change goals. We all know that many municipalities have declared climate emergencies. We're there to address those climate emergencies and to help with our experience meet their sustainability goals. Next slide. If anybody has any questions or wants to reach out, even if you're considering RNG or even if you have questions about consuming RNG, please reach out to us. We'd be happy to help you. Thank you.
Since 2010, the demand for rechargeable lithium-ion batteries has grown over 500%, with more than 15 million tons of spent lithium-ion batteries reaching the end of their life by 2030. That's an estimated increase of over 2,000% of lithium-ion battery waste growth in the coming 10 years. Focused on this urgent global challenge is Li-Cycle's scalable, sustainable, and safe lithium-ion battery resource recovery solution. We're the only company that takes in any type of lithium-ion battery and produces battery-grade lithium-ion battery chemicals.
Li-Cycle's spoke and hub infrastructure features a validated two-stage mechanical size reduction process and hydrometallurgical process to recycle any kind of lithium-ion batteries, irrespective of battery chemistry, previous application, or use. Our commercial Spoke 1 is already fully operational here in Kingston, Ontario, and is ramping to 5,000 tons per year of lithium-ion batteries. Construction is underway of our second commercial facility in Rochester, New York, with additional facilities planned for the United States, China, Europe, and Asia as we continue to grow our recycling capacity around the world. final stages of engineering of our commercial Hub 1 facility in Rochester, New York is currently underway. The hub will be a major producer of critical battery materials in North America, and the only facility capable of producing all the critical materials that go into our lithium-ion batteries today. With the goal of closing the supply chain loop, Li-Cycle's technology provides an environmental and economic, sustainable way of processing and recycling lithium-ion batteries.
Our technology is patented, commercial, and proven. Our recoveries are over 95%. And it is the only technology to successfully recover core battery-grade materials, including lithium carbonate, nickel, cobalt, and much more. Li-Cycle is on a mission to transform lithium-ion batteries from being a waste into a circular and sustainable product. And we're excited about the opportunity that Li-Cycle represents. Li-Cycle, securing a sustainable future for our environment.
Thanks to everyone who presented in cluster number 1. We're moving on to cluster number 2, energy storage. And we'll be starting with peak power, followed by Stantec, TROS, and Switch. So we'll start with peak power. Thank you.
Hi, everyone, and thank you, Belinda. My name is Mabel, and I'm the Senior Manager of Peak Power's Vehicle to Grid Integration Group. Next slide, please. For a little bit of background on Peak Power, we're a leading software provider solving problems at the intersection of the built environment and energy markets. We're a startup founded here in Toronto, and we also have a presence in the US as well. And we've received grants from the Canadian federal government as well as Ontario government to help commercialize innovative clean energy technologies. Our lead investor is Osmington Inc., a commercial real estate company owned by David Thompson, who's chairman of Thomson Reuters. And we have a strategic partnership with Ontario Power Generation for our vehicle to grid project, Peak Drive, which is the project I'll be talking about today. Next slide, please. I'll start with a problem definition. Our electric grid infrastructure is sized for the peak moments of demand in the year. So imagine if our roadways were sized to accommodate holiday rush hour traffic and empty the rest of the year. That's clearly an unsustainable business model, but traffic jams are acceptable and blackouts are not. So our advanced analytics enable us to forecast those moments of peak demand and enable cost-effective deployment of what we call grid edge assets, such as energy storage, electric vehicles, solar, and other distributed energy resources to offset that infrastructure cost of sizing the grid to meet those peak moments of demand. Next slide, please. Now, how do electric vehicles play into this? Electric vehicles will soon be the most common distributed energy resource, which is going to create either a big problem or a big opportunity for the grid. Our current grid simply couldn't accommodate the demand if our entire vehicle fleet converted to electric vehicles today. And yet we all know that switching to electric vehicles will be critical to reducing our emissions and meeting climate targets. As a reference point, a single electric vehicle easily doubles an individual household's peak demand, and the time of that demand coincides with the existing grid peak in Ontario when everybody comes home from work. So we know that smart charging in some shape or form is going to be a necessity to enable that transition. However, it also represents a significant opportunity. Vehicles have a very low utilization factor. On average, they spend up to 95% of the time parked on driveways and parking lots. Vehicle to grid technology refers to using the batteries in a vehicle like you would a normal battery with bidirectional charging capability, so it can feed energy back to the grid when it's needed. So vehicle to grid technology has the potential to both solve our, or help meet our peak capacity issues on the grid at up to 10 times less cost than stationary storage. And it brings a new revenue stream, which can decrease the cost of ownership of electric vehicles. And we've seen in recent years the power of new business models that enable additional revenues from personal vehicles, such as Uber and Lyft. Next slide, please. This graphic depicts our vision of using electric vehicles alongside energy storage resources to reduce those moments of peak demand. Next slide, please. This is an image of one of our peak drive sites in Toronto, which is also my Zoom background, as you can see. We have 2 sites with each with 10 Nissan Leafs and 10 bidirectional chargers located in office buildings. Some of our vehicles are leased to people who live or work downtown, and others are offered for short-term rental on a platform called Chiro. So if you're interested in participating in our pilot project and leasing or renting an EV, drop me an email. Next slide, please. Our Peak Drive project is also part of a broader initiative, which is going to be one of the largest transactive energy projects in the world, based right here in Toronto. Peak Power has received a $7.6 million zero interest loan from FedDev to support this pilot project. And we've partnered with all levels of local electricity stakeholders. The project will include 20 to 30 buildings with energy storage and IoT sensors, and around 100 electric vehicles, all with bidirectional charging systems. And these will be operated by Peak Power's energy market platform to aggregate and optimize the operation of all of these distributed energy resources, responding to real-time market signals. Next slide, please. So here's an example of how it all works together as a virtual power plant. And this is actually an example we demonstrated earlier this year. We dispatched 3 different types of energy assets. So that included behavioral demand response at buildings, stationary energy storage in the form of large batteries, as well as vehicle to grid technology. And this is the first time, to our knowledge, that electric vehicles have ever been dispatched in response to a real-time demand response signal from a utility. So that concludes my presentation for today. Thank you so much for your time. It's a pleasure participating, and please don't hesitate to reach out with any questions.
So we're ready to go with Stantec and Jose. Are you able to unmute your line, Jose?
There we go. Hello, my name is Jose Walsh and I work for Stantec Consulting. I'm going to present to you a solar and battery microgrid at Algonquin College, Woodruff, the campus which serves over 21,000 students. The project was designed by Stantec Consulting and built by Siemens Canada in 2018 and 2019. Next slide. The microgrid consists of a 500 kilowatt DC solar photovoltaic array and a 500 kilowatt AC lithium-ion battery. Algonquin College intends to use the solar PV and battery installation as an educational laboratory for students, and also to supply electricity to the campus and reduce energy costs. It's part of Algonquin's plan to become carbon neutral, and it's a pilot project for a larger microgrid, which will include a 5 megawatt battery energy storage system, and also helps reduce electricity costs. The Algonquin College determined that together the battery and solar make financial sense, and the system. The solar array is distributed on 2 rooftops, as can. Next slide. The solar array. Next slide. The solar array is distributed on 2 rooftops, as can be seen in this conceptual diagram, where we've analyzed several rooftops, and it was determined that there were sufficient areas on buildings J and N, and sufficient structural capacity. In addition, the battery system is connected to the main building switch panel, where you can see the blue square. The project supplies approximately 4% of the entire campus's electricity grid, but together with the existing microgrid of combined heat and power, it can pretty much power the entire campus. Next slide. The entire project, it was estimated to cost $3.2 million, with an annual operational cost of $16,000 per year. That's equivalent to about 8% of its equivalent earnings. And with the assumption that the cost of electricity is going to increase at 3% per year, the project has an internal rate of return of 8.2% and a 17-year simple payback. The majority of the cost is upfront, but if it's spread out through a 30-year period, the equivalent cost of electricity is 9.5 cents per kilowatt hour, which is already cheaper than the existing electricity costs. Next slide. The developments of the project took about 10 months, where the feasibility was about 5 weeks, a detailed design 6 weeks, and then 4 months for the permitting process, and a total of 6 months for the construction of the site. Next. Some important design aspects to highlight for other similar projects are to perform an accurate rooftop survey, so that during construction, the modules aren't laid over any drains or other roof obstructions. Also to perform a roof structural assessment, and to perform a geotechnical investigation of where the battery container is going to be placed, because these battery containers are very heavy. And another important item is to review the building's existing electrical protection. So that needs protection and controls assessment in addition to an arc flash assessment, because when you're operating as an island microgrid, the fault currents are different than when you're grid connected. And it's important to understand how the microgrid is going to be used, what it's going to be used for, so that the energy management system and the microgrid controller function correctly. Next. Some advantages of the installation of solar with battery are that it allows stable PV generation. An intermittent source such as solar, when it surpasses 10% of the electricity grid, it creates fluctuations in the energy supply. It also doesn't provide any noise, no air pollution, gases. It's a good backup power and provides energy security. And it's a seamless transition when it operates in island mode for the critical loads. And it's going to help reduce the campus electricity costs by using solar energy and using it during the times that the electricity is much more expensive. Thank you. That's the end of the presentation.
Everyone, choice, and thank you OSEA and OCE for organizing and hosting. I'm sorry that I cannot share my beautiful face today. I have no video. I hope you excuse me. So I'm gonna go on with the presentation. We actually it's a EV charging station. Next slide, please. So we are a battery energy storage system technology company. We established in 2018, and already we have projects in Canada and US and UK. And greetings from our CEO Vienna, stating that the mission statement that is to make the grid and renewable energy more efficient, reliable, and environmentally friendly through energy storage. Next one, please. I'm not going to go on much about the EVs and the growth and the situation about EV charging stations here. No matter what, in 2020, things were slowed down because of obvious reasons. The growth and the trend is over there, though. And we know that within the next 10 years, is going to be an increase of both EV charging stations, and of course, together with that, the demand of electricity energy, as the previous presenters talked about. Next slide, please. So the project we have at Sky is, as you can see from the picture, it has, on the left-hand side, you can see the battery a bit under the carport. You can see the PCS, the carport, and close to the cars, slightly you can see two EV charging stations. One is level 2, one is level 3. If we go to the next one, I'm gonna share with you the applications, a bit about the project. So we started it in 2019. It was completed in 2019. That was something from Sky Energy. They tried to make, as you can see in the applications after, a multi-phased and multi-stacked benefits. What we did there, we developed for them 130 kilowatts, 100 kilowatt hours BSS, and now it's integrated into a vehicle-to-grid hybrid power conversion system at Skies. So this system is online, iCloud, and is monitored remotely. Next one, please. So these are the stack kind of benefits. Obviously, peak shaving, obviously backup power, obviously demand bill management and response, and obviously, again, renewable storage and firming. So these are very easy to understand for the people who are in the industry, but we find out that there are more and more people we talk to that they are not that well informed. So this is an opportunity for everybody as far as the energy storage and the energy efficiency in general, not only in Canada that we talk to. So if we go to the next one, please. So we support, of course, the Ontario grid, and as I mentioned before about the demand response, it's going the demand for the EVs from EVs at until standalone. It's going to be about 5.2% increase for the next 10 years, according to Bloomberg. So we encourage the adoption of EVs by providing consistent and reliable energy at charging stations. And this is my last slide. Thank you very much. And in case you have any questions, please come back to me. Thank you.
Good morning, everyone. So we're making it easier for everyone to drive electric, and we're also helping real estate developers and utilities capture the massive opportunity from growing electric vehicle adoption. I'm Carter Lee, CEO at Switch, an energy tech company that has over 400 electric vehicle charging deployments and over $2 million in commercial sales. Next slide, please. So when we think of electric vehicles and the challenges of electric vehicle ownership, the question that comes up time and time again is, how do I own an electric vehicle if I don't have a place to charge? Next slide. 25% of electric vehicle owners don't have access to home charging. By 2022, there's going to be over 5 million electric vehicle owners living in condos and apartments without access to charging. And it's a challenge we're seeing mirrored across the world from Toronto to New York to Shanghai. Next slide. To address the unique challenges of urban electric vehicle ownership, we've built an EV charging platform designed specifically for high-density urban settings. Key features include scheduling to maximize charger usage and revenue, enforcement to prevent loitering of fully charged and non-EVs, open standards compliance to ensure greater choice and flexibility, as well as smart energy management to maximize existing energy infrastructure and minimize upgrade costs. Next slide. So what's the result? Well, everyone wins. Electric vehicle drivers get charging access when and when they need it most. Building owners increase property values, gain new revenue streams, and utilities maximize load growth while minimizing costly infrastructure upgrades. Next slide. So where are we at? Well, we fully commercialized with customers across the North America. Since 2018, we've generated over $2 million of sales. Over $2 million of sales, our pipeline's over 3 million, and we've become cash flow positive. We've developed a strong set of strategic partnerships with building services and grid management companies across Canada. We've also carved a path into the US market as a software partner to a major hardware supplier. And we're working with utilities and technology demonstration projects to further expand our base of deployments. Next slide. So we're moving into an age where autonomous vehicles charge wirelessly, where electric vehicles charge and discharge energy to support the grid, and where blockchain facilitates the distributed energy economy. There's an enormous opportunity for these emerging technologies to create value for electric vehicle owners, as well as real estate developers and utilities, and we're leading multi-million-dollar projects to integrate these technologies to help capture this massive opportunity. Next slide. So at Switch, we envision a world where every electric vehicle has a place to charge, wherever that may be. Thank you.
Thank you. I'd like to say thanks to OSEA for putting on Green Energy Doors Open. I think it's a great initiative, and we're happy to be here. Great, thanks. So just a little bit about who Guelph Solar is. We've been in business for over a decade. We have experience with a wide range of solar equipment. If it's solar or battery storage or solar thermal, we've probably worked on it. We've survived the solar incentive roller coaster. Back in the microfit days, there were many companies just like us, and now there are very few. And we survived it with a 5-star Google rating, and it's mostly because we have a passionate staff that really believe in the green economy. We're focused on providing solutions to our customers that are sustainable and give them independence and are also a wise investment. We're installing systems now that have a 25-year warranty, and so they're going to make up an important part of the distributed energy system that will support our grid as we adopt things like electric cars that people have been talking about, and the grid's going to need more support for all the charging. Next slide, please. It would be tough to put on a presentation about this subject in 2020 without talking about Elon. Elon has a dream that we will all live in these very modern houses. We'll produce our energy on the roof to charge our car and to run the power in our house. And we'll have a power wall in the house as well to provide power when the lights go out. And with COVID, we're actually seeing an increase in our business. And I think that people are, with all the uncertainty, I think they're looking for resilience, and a sustainable solution. And being able to produce your own power really provides you with that. So I'd like to leave you with a video that showcases a system that I think even Elon would approve of, but I'm happy to answer any questions. So thank you for your time.
I'm Dave with Guelph Solar, and we've been designing, installing, and maintaining solar systems for over a decade.
What I like to do, I really love technology and trying out new things, and thought it was really great when they came along with their power walls, because I thought it would be great to integrate that with solar power.
We have 31 kilowatts of solar on the roof and 12 Tesla power walls in the basement, providing 162 kilowatt hours of backup power. It's the largest Tesla power wall installation in Canada.
It's really nice having the power walls because they're kind of the brains behind understanding how energy is used in your house, and it's sort of monitoring how you're using energy over time and trying to think when it's best to use the sun, when it's best to use the batteries, when it's best to use the grid. It's cool because the solar panels are really hidden away in the sense that they're on the roof, and you'd have to really look for them to see they're there, and the power's going to have to be out for a few days before I start losing power, and I think that's pretty neat.
This system is a technical masterpiece. We designed custom racking to maintain the aesthetic appeal from the ground the way the customer wanted it, and also to deal with some complex roof structures to get the panels up above the shade lines.
In fact, the house looks better with the solar panels on it than without the solar panels. And that says a lot. Like, you look at the way they were installed and they're just modern, you know, they just look terrific, and clearly add to the value of this house and the aesthetics of this house. All of the energy to drive the cars comes from my house. I charge them at home, almost never use outside charging systems. And this is going to make that even better because I'm going to be using the solar power to actually drive. It's a very environmentally friendly, sustainable way of doing things, and taking a little bit of pressure off the grid. Guelph Solar worked through the whole design of the system, through all the approval processes which were required, meeting with inspectors, working with our home builder, Stephen Colson, to make sure that it fit and it integrated into our house. And they've just done a tremendous job because it is a complicated system, but they made it simple for me, which is what Guelph Solar has done a really nice job of.
Good morning. I'm Graham Lowry. I'm from North Shore Power Group. Our company is based in Northern Ontario, and we operate in a rather more fundamental part of renewable energy than some of the fantastic presentations that preceded us. But essentially, our business model is focused on generating electricity. So this presentation is about the projects that we've built in Northern Ontario. Next slide. So we're owned by a municipality. I started the company. I've been in renewable energy since the 1980s, starting with small hydro development when I was much younger. And eventually the municipality took over this company, and we've developed 124 projects around Ontario, from Ottawa to Rainy River, Sudbury, Manitoulin, London, Kitchener. So we have 4.4 megawatts of mostly solar in our generating portfolio. Next slide, please. We've provided quite a bit of economic benefit to the region. Blind River has had some economic setbacks with the closure of the mines in Elliott Lake and the demise of the logging industry in Northern Ontario. So we managed to produce quite a few person hours of employment, 30,000 hours during construction, and quite a bit of capital investment. And now we have a team of about 12 people at the moment heading into the winter season, providing O&M. Next slide. So this is just some pictures of some of the municipal roof microfits we've done on various buildings around town, the town hall, the fire hall, the water treatment plant, the sewage treatment plant, etc. Next slide. We've done some large scale fit projects, both trackers and fixed rooftop. The top left there, you're looking at the community center, which is also the hockey arena. The bottom, you're looking at the Blind River District Health Center. And then on the top right there, you're looking at a tracker project using trackers from Zonen from Germany. Next slide. We've done 62 residential ground mount microfits, so those are all trackers. Just pictures of them, in many cases on farmland where we just leased the space. We managed to get some contracts in the early days when corporations could hold contracts. So those have been good projects at 80 cents. Next slide. Done 45 residences with rooftop microfits, just pictures there of houses around town. Next slide. This goes back to my start in renewable energy. I was in my 20s, I guess that dates me, but I built the Scarf Lake. I rehabilitated a generating station which had been built before Ontario Hydro was even in that district of Northern Ontario. It was called the Cataract Power Generating Station. So the one on the left there from the aerial photo is called the Scarf Lake GS. We rebuilt it in 1987, and it has 2.4 megawatts of hydraulic capacity. And then in 91, I built the Chiblo Lake GS. I sold them years ago to a company that would be familiar to most of you, Algonquin Power. I sold them when I was in my early 30s. And then the owner recently, a few years ago, came back and asked if the company that I now operate would run them for them. So life is a big circle. I built these hydroelectric plants, and today my company is operating them again. Next slide. Just a picture of our head office and a Google Maps of Blind River, which many of you probably never heard of, but people there like to think it's the center of the universe. And I did supply a video, but I don't know if we're going to play it. So this is the industrial park in Blind River. This is a drone panorama, so you can get an idea of the beautiful countryside up there and the 200 acres of solar projects we've developed. There's 10 projects, 17,000 solar panels. The tracker projects you see were the projects that got a higher rate. Those are the 80-cent projects. By the time we built some of those fixed projects, the rates were down to the 30s or 50s. And so we couldn't afford to invest in trackers, but it's a beautiful part of Canada, or of Ontario and Canada, if you've never been there, the North Shore of Lake Huron. And if you ever are in town, stop by our shop and be happy to show you around the 200 acres of solar projects. That's it.
Hello, everybody. It's Jerry Foster. I'm the president and founder of Windular Research and Technologies. I'll go to the next slide. First of all, when people ask what we do, and my question back to them is certainly everybody has a smartphone. What people really don't understand is on the planet here, half of the telecom towers are run by some type of fossil fuel, diesel generators, and these are the towers that are in the remote areas around the planet that are making our smartphones operate. Next slide. So we have a very unique wind system that reduces operating costs of these remote towers, reduces its carbon footprint, and provide a long-term fixed power cost. Again, a lot of these towers that we do are towers that are on mountaintops areas that are very difficult with logistics with respect to diesel fuel, and our system is extremely unique with respect to how we put our system onto the existing tower infrastructure. Next slide. Our background is a combination of both telecommunication engineering and renewable energy. So we've been able to develop a very unique system. Everybody likes to ask who our competition is. Our competition at this point are diesel generators. There's nobody doing how we are applying our wind technology on telecom towers on the planet, which puts us in a space of innovation and also disruptions where we have attracted early adopters with respect to how our system operates to reduce the reliance on diesel generators. Next slide, please. Firstly, a lot of the remote towers that you do not see that are not in urban areas are very unpopulated. They have antennas at the very top and a great deal of real estate going all the way down to the bottom. So we can capture that real estate in order to attach our rail and system onto any type of tower structure. And then we put on our 10 kilowatt smart tracking wind system with our smart times monitoring system that allows data of how we are reducing the use of that diesel generator, taking it from a primary source to a emergency backup only. Next slide. We can adapt to any tower structure. These are various towers we've done around the world. Right here in Canada, we're under contract with Bell Canada doing towers in the north for them. Ones that are as high as 500-foot towers. We have our system at 200 feet. We were down in South America and Chile, and we work with Telenor Group out of Oslo, Norway, with towers in Pakistan. Next slide. Our times monitoring system is one that we can adapt to any type of data that the telecoms are looking for. One of the things that's interesting with the major telecoms around the world and the remote towers, they really don't have a good sense of what is going on at their sites. We've developed our own internal system that can, it's almost like a Lego building block system that we can monitor as much data as they need. Right now for Bell Canada in the north, we are their primary source of all their data points with respect to what is going on at their sites besides just what our wind system is doing. Next slide. Again, we have full engineering services. We do engineering analysis on all the towers before we put our systems on, and we can adapt our system to any type of tower by using either 4 90-degree angles or 3 120-degree angles with straight sections, where our system is a wind system that automatically has a smart tracking feature to it, meaning that it knows where to position itself because we are reading RPMs, we're reading wind direction and wind speed at all times, and then it autonomously understands where to position itself. More importantly, in a lot of these remote areas, our system also knows when to move around 180 degrees around the tower to go into a protection mode when a very turbulent wind system comes through, which has been, for a lot of the telecoms who have tried wind systems before, their demise has been in very remote areas. Mother Nature can do some extremely nasty things where they blow wind turbines apart. Our system has auto tracking, so it understands where it should be, but at the same time can go into a self protection mode that allows the system to have longevity to its assets. Next slide. Again, we focus on providing a renewable energy solution to the telecoms with respect to wind in areas where solar cannot be applied. A lot of times in these very remote areas in the mountains and obscure areas, there is not the ability to put in solar. We do have a solar system as well. So we are both a wind and a solar company that do both, but at the end of the day, we provide a solution to take their diesel generator that is running the system and make it as a emergency backup system only. In the case of Bell Canada, we've been able to reduce that by almost 90%, and in Telenor Group, we've been running 120% of their power through our system, so their generators are really not operational at all. Next slide. And if you go to our website, you will see videos of our system in operation, both in Canada here and overseas. And if there's any questions, I certainly welcome anybody to reach out to me. And I thank OSEA and OCE for putting on this event, as it is one that is good to understand. This is a Canadian company with a fantastic technology on a world stage that we're strategically growing our company. Thank you very much.
Thanks, Jerry. That was really interesting and a great lead into my presentation. My name is Carleen Dudek, and I am the CEO of AP Renewables. Next slide, please. So AP Renewables is a growing startup based in Hamilton, Ontario. The company was founded in 2017 by a team with more than a decade of experience working in wind turbine performance management and engineering, including with major wind turbine manufacturers. Our first product was the Static and Lightning Protection System, which is a grounding brush system, I can show it to you here, that protects turbine electronics from lightning and static damage. And the product delivers an average increase of 1.8% in annual energy production for susceptible turbines, which generates tens of thousands of dollars in increased revenue for a typical wind farm annually. And today we continue to develop industry-leading software and hardware products that help turbine owner-operators reduce operations costs and increase renewable energy production. So our most recent product development is the SCADA Scope product series, which combines a series of performance optimization tools designed to capture the nuances and in-house expertise of each wind farm's operation and to deliver actions from wind turbine data. The product suite includes the SCADA Scope DT field unit, which is a diagnostic tool that gives wind farm operators access to the high-resolution data that they need to accurately and quickly identify underperforming assets, as well as our insights reports, which deliver actionable insights to stakeholders at all levels of renewable operations. At the ownership level, this means that asset managers are provided with a reliability-centered view of the asset's past, present, and future performance. And at the operations level, these products ensure that the operations and maintenance team can quickly identify the root cause of turbine failures, and that technicians arrive at the wind farm site with a clear understanding of how to solve the problems. This not only reduces maintenance costs and service time, but limits the health and safety risks for those employees. And these issues have really become increasingly important during COVID-19 as firms are trying to limit the risks created by on-site in-person activities and encourage remote working. So combined, the SCADA Scope product series really enables owner-operators to increase profits by reducing their operations costs and increase revenue through increased energy production. Next slide, please. So our current customers include some of North America's largest wind turbine owner-operators and major utilities. And we have product trials taking place at wind farms globally. We also have active R&D partnerships with wind farms in Ontario, Alberta, and the Northeast US. And we're actively looking for new strategic partners within the renewable ecosystem in Ontario. Next slide, please. So we believe that we can lead in promoting a circular economy within the renewable energy sector by providing the tools and the expertise that allow more clean energy generation from existing assets, while also extending the lifetime of those investments. To successfully manage and maintain assets remotely, we know that owner-operators and their operations and asset management teams need specific targeted actions to enable robust and time-sensitive maintenance and production management. And our SCADA Scope series has been designed with that in mind by providing integrated data management tools and actionable insights. We can really reduce those costs and increase the asset service life. And because remote diagnostics is reliant on good telecommunications, we are designing our products to be 5G enabled. In Ontario, this will allow the asset owners to harness a remote workforce to service assets in rural and remote locations, and ultimately to exploit the full revenue generation potential of their assets. Next slide, please. So we do feel very fortunate to be operating within Ontario because of the history of investment in renewable energy and specifically wind energy in the province. This has created an extensive network of ownership and operation, as well as a highly skilled workforce. So this means that we have access to both the wind turbines and the talent base that's necessary to develop and deploy our technologies right here in Ontario. Next slide, please. And so I would like to thank you today for the time. Thank OCE and OSEA for inviting us to speak. And we look forward to continuing to create partnerships within the Ontario renewable energy sector, and also to taking any questions that you might have later on this morning and this afternoon. Thank you.
Thank you so much, Carleen, and thank you to everyone who just presented. We'd like to move on to our next cluster, which is focusing on energy efficiency and grid firming technologies. We have Blue Wave AI, followed by the City of Aurelia. Unfortunately, our presenters from LoomSmart are not able to join us today, so we'll start with Blue Wave and then City of Aurelia. Thank you.
Okay, thank you so much. What a group of impressive company and an ecosystem we are playing here in Ontario. I would like to thank OC for organizing this event, providing us the opportunity to talk, and Balinder as well for reaching out and organizing the event. So my name is Mustafa Farokhavadi, and I'm the Senior Director of Technology at Blue Wave AI. Next slide, please. So a little bit of an introduction of who we are. We are a software as a service company founded in 2017. So far raised over $5 million in between pre-seed and seed rounds, including $2.4 million from Sustainable Development Technology Canada grant, and obviously OC grants that have contributed to our pre-seed rounds as well. We are a pretty active company in terms of our IP portfolio, have been granted a couple of USPTOs and have active USPTO applications on the intersection of power systems, machine learning, and obviously data science. We have implemented the first AI-enabled dispatch in Canadian electric utility for the city of Summerside, Summerside Electric at the Prince Edward Island. And we are aiming to becoming a recognized premier global cleantech company by the end of this year, and we are on path for that essentially by a few awards that we have received so far. So if you go to the next slide. In terms of our customers and partners ecosystem, we are active on 3 continents. In North America, an array of partners and customers, including Hydro Ottawa in our backyard, Summerside, as I mentioned, Tuglig Energy, and IESO. We are also working with Green Cat Renewables in UK and Tata Power in India, and an array of partners as well, including IBM and Microsoft. Next slide, please. So this is essentially the domain we are operating in, is to maximize the utilization ratio of renewable energies. In smart grids, as you know, renewables in the form of utility scale, renewable farms, and distributed energy resources, they are not fully utilized. Their potential is not fully revealed due to sub-optimized operation. The penetration cannot go beyond a certain level because the operator cannot maintain the system reliability and the stability of operation. And because of that, essentially most of the energy is still coming from thermal fossil fuel based generators. So we are in the domain to change the story and facilitate the penetration of renewable and distributed energy resources. These also include electric vehicles and electrification of transportation in both developed and developed countries. Next slide, please. So our product is an IoT platform broken in between one center module and multiple edge modules that is hosted in the cloud, currently in Microsoft Azure. And our customers include utility scale renewable generation, including wind farms and solar farms. And on the distribution side, it includes distribution utility and distribution system operators, grid-tied industrial campus enterprises, off-grid microgrids, and electric fleet vehicle operators, essentially. We are targeting a global estimated market of close to $6 billion divided in between these customer targets. Next slide, please. A little bit of our first customers. So we have close to 6-7 ongoing projects at the moment. The first enabler customer for Blue Wave was the city of Summerside, a very interesting smart grid. It's not a big city, it's actually the total demand is, the peak of demand is close to 25 megawatts. So we are not dealing with a large city. On the other hand, it's a very interesting smart grid. They have on-site 12 megawatts of wind farm, which produce close to half of their energy need throughout the year, and the rest of the energy is imported from the transmission level operator, the upper grid essentially. And what the problem was at the city was optimal scheduling of their energy resources, including their wind farm, including their import from the upper grid, and the city thermal storages as well. So we went in, we implemented our product, the same IoT cloud-based product that I described, and we are currently operating there for close to a year. I guess our anniversary with Summerside is actually happening in November, if I remember correctly. And we essentially brought double the annual operational savings that they have from their wind turbine. By a factor of 2. So this is a customer success story for our first customer. We are on path and we are reproducing the same amount, the same order of savings, operational savings, and operational penalty reductions for our other customers. Again, we have 6 active projects. Please visit our website. It's the same, bluewave-ai.com. We are received major recognitions within the past couple of years. These include the Smart Grid category winner at the World Energy Council in Abu Dhabi, among close to 1,500 participants. We received the IEEE Ottawa Section Cleantech Company of the Year Award. We are among the top 20 early startups of SIX, and we are also among the top 3 finalists of the German energy agency DINA cleantech startups. So I believe that would bring an end to my presentation today. Again, I encourage everyone, please reach out to us. We are very open to partnerships in the cleantech, renewable energy, smart grid domain. And we have a few array of white papers and other info that would help you to better understand our operation. Again, thank you, OC, for providing us the opportunity. Really appreciate to be able to talk at this event. Thank you.
Thank you for the opportunity to share some of the City of Aurelia's sustainable initiatives, including the emerging role of Sustainable Aurelia as a key partner in our quest to make Aurelia a more sustainable city. Shortly after being re-elected in 2018, Stan, right here, visited me on behalf of a small group with a proposal on how to make Aurelia a more sustainable city. Soon after that, I brought together the original group with some like-minded people to create an active network of engaged citizens and partnerships focused on sustainable solutions. And so was born the Mayor's Task Force on Sustainability. The group launched with a full-day public workshop with a goal to conceive, promote, and eventually roll out a wide portfolio of grassroots actions that would promote sustainability in our community. Over 180 citizens participated and generated almost 200 ideas. This task force subsequently transformed into an independent, not-for-profit organization, Sustainable Aurelia, that has become an active partner for the city and a hub for the citizens to source information, support, and a voice for practical, sustainable change. And at the same time, Council put the finishing touches on a strategic plan, realizing our potential, which highlights our commitment to sustainability. As we look ahead to post-pandemic times, I feel we are poised to build upon the work and the momentum already in place to support sustainable projects that will preserve a continuing quality of life in Aurelia.
Thank you, Mayor Clark. The City of Aurelia is committed to sustainability in its strategic plan and has also undertaken a number of new energy efficiency initiatives. Could you please share a few examples of these projects with us?
Be happy to, Stan. The city's 2020 initiative to upgrade street lighting to LED technology, for example, has had a particular focus on energy savings and efficiencies beyond those achieved with just LED lights. Each upgraded light fixture is also equipped with a smart lighting control node, whereby the city is able to view and monitor lighting levels throughout its network remotely. This allows potential lighting issues and deficiencies to be addressed more rapidly and to ensure the network is operating at optimal level. Once installed, we anticipate the new technology will reduce the city's greenhouse gas emissions by 70 metric tons a year, equivalent to greenhouse gases stored in 80 acres of forest, or the energy required to charge 9 million cell phones. The supplier for this project is Depolymerisation, a Canadian-based supplier in Quebec. Then there's the implementation of a water usage consumer portal the City of Orillia launched in 2019. This is a leading-edge technology, and it provides real-time, personalized information about household water usage that enables residents and businesses to make informed decisions on water consumption. Transmitters attached to a customer's home or building relay water consumption data through a wireless communications platform that feeds into the city's water utilities database. The user-friendly portal allows customers to monitor their water usage, understand current and previous billing, and optimize water conservation through real-time usage monitoring. So those are a couple of the city's recent energy conservation initiatives that will also save the citizens of Orillia money. Now let's take a moment to highlight some of what Sustainable Orillia has been doing, particularly now as October 2020 is Sustainable Orillia Month.
Let's start with electric vehicles. Encouraging consumer consideration and adoption of zero-emission vehicles is part of Sustainable Orillia's initiatives and is a passion of mine as well, personally. Last year, we coordinated an electric vehicle demonstration weekend during which we saw over 300 attendees inspecting 35 vehicles up close. They had a chance to not only inspect them, but to discuss, view, sit in, and drive them, while learning from the owners as well as from specialists, such as our partners at Plug and Drive. The Ontario EV Society, the Tesla Owners Club, and Orillia Square Mall and other local businesses were sponsors. Anecdotally, I'm aware of several purchases of EVs made as a direct result of this event. We were looking forward to a similar event this year, but due to COVID-19, we replaced it with a All You Ever Want to Know About Electric Vehicles webinar as part of this year's Sustainable Orillia Month online lineup. Our 2019 Sustainable Orillia Month program includes a wide range of seminars and special events, many of which have an energy focus. Bob Willard, a renowned expert in sustainability, last year, for example, spoke to local business about the ROI of sustainability and how it calculates the ROI of energy-saving projects. This seminar was well received, and several of our local companies have followed up with Bob's recommendations. As mentioned earlier, we've gone entirely virtual this year. Throughout the month, we are promoting 9 free webinars from a variety of presenters, 4 of which are directly related to energy sustainability. They can be found listed on our Sustainability Orillia website. Despite the challenges to stay on message during these times, we're pleased with our progress to date, and we want to thank our ever-expanding network of community, media, and individual partners for their great support. And that includes our appreciation to be part of this year's Green Energy Doors Open. Many thanks to OSEA. We look forward to continuing our collaboration in the future. Thank you for this opportunity and your attention.
Thanks to our speakers in that last category. And coming up in cluster 5, we have carbon cure and sulfachar.
I guess we were gonna play a video. Maybe you guys can try and figure that out while I just deliver my slides, and then we'll circle back on that. So hi everybody, thanks for having me here today. My name is Jennifer Wagner. I'm president of a company called Carbon Cure Technologies. We are a Canadian clean tech company, and we're sort of in that rapid scaling mode. Our goal is to reduce 500 megatons of carbon dioxide annually. And where we operate is in the concrete space. So we're using carbon dioxide to improve ready-mix performance and sustainability. Next slide, please. Everyone's familiar with concrete. It's the most abundant man-made material on Earth. And there's been great effort made to try to reduce the carbon footprint of that sector. We have a bolt-on technology, you can see here on the right-hand side, that gets directly installed onto concrete plants and allows them to inject carbon dioxide into the concrete to improve the compressive strength. And that improvement in the compressive strength of the concrete allows the producer to optimize their mix designs and actually realize some cost savings as well, which is pretty unique to the space. We're not just offering greener concrete, but it's also more economical for the producer to produce. Next slide, please. So the company started out of Halifax, Nova Scotia, and we've been working with OCE for the last few years to deploy demonstration projects across Ontario. And as you can see here on the map, we've grown fairly quickly over the last few years. When I started with the company back in 2010, we had one customer, and we just signed, I think it's closer to our 300th plant now. We're operating all across North America, into Asia, and actually this map is now outdated. We just signed a couple of plants in Bolivia and Japan. So growing quite quickly. Next slide, please. If you'd like to learn more, please visit our website, carboncure.com. The way I like to leave it with everybody is there's a role that everyone can play, whether you're a specifier, a city planner, a policymaker, an investor. There's some role that you can play in helping to decarbonize the industry, so we encourage you to join us. I'm hoping we can get that video up. If not, then you can check out our site and hopefully find it there. Great, thank you.
The world is expected to add more than 2 trillion square feet of new building space by 2060. That's the equivalent of adding another New York City every month for the next 40 years. Many of these buildings will be made using cement, a massive emitter of greenhouse gases. But a company in Canada discovered an innovative way to reduce cement's carbon footprint.
The effects of climate change are going to happen. We're seeing it every day, but this is a solvable problem. Our industry can decarbonize. Cement is the glue, it's the active ingredient in making concrete, and is the product that we build modern society with.
People often ask, what is the difference between cement and concrete? Cement is really the chemistry behind concrete. A simple analogy would be if you're baking a cake. The flour would be the cement, and the cake would be the concrete, the finished product.
To make concrete, you dig up limestone from the ground, and then you run that through a kiln. Each pound of limestone that you put into this kiln, 1/2 goes up into the atmosphere as CO2. CarbonCure is a technology company helping concrete producers transition into the new low-carbon economy. We developed a technology that bolts on to an existing concrete plant. We're starting with a greenhouse gas, a harmful waste product, and we're turning that into value. We add a small amount of CO2 to react with the chemistry from cement that allows you to create a higher strength concrete. Carbon utilization is not just some abstract idea. It's not just happening in the lab. It's happening in the real world.
The concrete industry has worked for years on sustainability, and so now we're looking for new technology. And CarbonCure sequesters that CO2 into the concrete, locks it in forever.
Then you can actually lower the amount of cement in that concrete. It's really taken hold, and it's building real things that we can live in and drive on every single day, with overpasses and roads, airports, aquariums, or it could even be tech campuses. CarbonCure is on a mission to reduce 500 megatons of CO2 emissions per year. That is the equivalent of taking 100 million cars off the road, or the equivalent of the CO2 reductions from 500 million acres of trees annually.
We're finding in the marketplace, both with our customers and internally, people are proud to work for someplace that is taking care of the environment.
I'm doing it for my family. I'm doing it for my daughter. There's a real human toll to climate change, but absolutely the solutions are there.
Char Technologies was initially founded to commercialize some biocarbon research I had been conducting at the University of Toronto, where we were taking low-value materials and turning them into high-value carbon products. Our first product out of the lab, Sulfachar, takes low-value anaerobic digestate and turns it into high-value activated charcoal. Our newly commissioned biocarbon plant will be producing two products. The first is Sulfachar and the second is CleanFire. For Sulfachar, we'll be producing our first commercial batches and getting them into our clients' hands. For CleanFire, we'll be producing 20 tons of CleanFire for our testing partner, ArcelorMittal Dofasco, where they'll be testing it in their blast furnaces as a carbon neutral replacement for combusting coal. Sulfachar acts as a filter for renewable natural gas. So that's gas that comes from organic waste as it decomposes. So we're talking wastewater treatment plants or landfills or even green bin organic waste processing. That creates methane, which is great. It can be captured and utilized as a natural gas replacement, but it also has sulfur in it. And what Sulfachar does is pull that sulfur out of the gas so it can be used and converts it into a fertilizer product. CleanFire is a high energy carbon. We create a carbon that has higher energy than coal and can be used directly as a coal replacement for large industrial users, including blast furnaces and cement kilns. Like Sulfachar, CleanFire is made from very low value materials, including wood waste, things like chipped pallets, or even some sewage sludges. We can take low value material and turn it into high value carbon. The real excitement around CleanFire is that not only can we offset coal and our clients see the same or better energy, we can actually allow them to burn a product that creates no greenhouse gases in its use. Bench scale, we're making kilograms per day. This facility can make up to 5 tons of product per day.
So this unit uses 4 stages to the process. The first process is the feed handling. So we load super sacks into the loading hopper. They then get augered and up a bucket elevator through a rotary valve. That's the airlock on the front side of the process. Then they go into what we call the feeding hopper. From there, we move into the second stage of the process, which is the pyrolysis or the activation. Stage 3 is the solids handling / cooling side of things. So as the material drops out of the heat tube into the first cooling screw, we get a direct spray of water to get some rapid quenching of the material, and then passes through a second cooling screw, then through a double dump valve, which is basically just 2 flaps that alternate to keep an airlock on the back end of the process, and then through a third cooling screw before it gets discharged into a super sack waiting on the other end.
Char's big opportunity for growth is through our biocarbon development. And as we bring CleanFire to market, it will really represent a step change from where Char Technologies is today.
Thank you to Carbon Cure and to Char Technologies. Our next cluster is focusing on emerging carbon-free technologies, and we'll be starting with Moltex Energy, followed by hydrogenics and planetary hydrogen.
Hello, my name is Erin Polka. I'm the Director of Communications at Moltex Energy. So first of all, I just want to say a quick thank you to OSEA for inviting me to be a part of this session. I think nuclear is an important part of any conversation about reducing emissions and reaching net zero, because it's clean, it's reliable, it's versatile, it's incredibly safe, and thanks to major innovations, it's also very inexpensive. So next slide, a little bit about Moltex. We were founded in 2014 in the UK, based on the belief that nuclear should be leading in the fight against climate change, combined with a frustration that we weren't really fulfilling this role. And in 2018, we moved to Canada because of the regulatory environment, which is friendly towards novel technologies such as our own. We were also one of 2 companies that NB Power, which is a utility in New Brunswick, selected from over 90 applicants to advance the design of our reactor for the goal of commercial operation in New Brunswick by 2030. We now have a well-established team in New Brunswick. We're working towards the development of the local supply chain and building partnerships with First Nations groups and other key stakeholders. And at this time, we're finalizing the concept design of our reactor, and we'll soon be moving into the engineering design phase. Next page, please. So the reactor that we're developing is called the stable salt reactor, and it has three main advantages. One, it costs less than other small modular reactors on the market, and significantly less than conventional large reactors based on power output. Two, it contributes towards waste minimization because instead of burning uranium fuel, it burns used CANDU fuel. And three, it enables the development, the further development of intermittent renewables because it can act as a peaking plant, storing energy it creates when it isn't used, when it isn't needed on the grid, and then supplying it to the grid when it's required. And next page, please. I want to expand really quickly on each of those three benefits. First of all, cost. With regards to cost, this chart shows the levelized cost of nuclear energy over time. And as you can see, nuclear was very inexpensive in the 70s and 80s. But when the accidents at Chernobyl and 3 Mile Island took place, the industry responded by adding layers of protection to ensure nuclear remained safe. And it did, but now it did so at a much higher cost. And so what Moltex has done is they basically changed the paradigm of reactor safety. Instead of adding layers of protection to keep the reactor safe, they've eliminated the hazards altogether. So it's inherently safe, and as a result, much less expensive to build and operate. Next slide, please. The next thing is to consider is waste. Canada's been burning uranium fuel for about 60 years, and that's created a lot of used fuel. And right now it's located on site where it was created, waiting for us to figure out what to do with it. Moltex has a solution for all of this waste, and it can use it to create clean electricity. And we've done the math. 12 500 megawatt reactors could consume all of Canada's used fuel. There would be a little bit left over, but really, you know, we're talking a 50th to 100th of the amount, and it would be far less radioactive. Next slide, please. Last point I want to make is that Moltex doesn't see itself as a standalone solution or an alternative to renewable energy. We see ourselves as part of a clean energy mix that includes nuclear and hydro and wind and solar and tidal and carbon capture and all the other low or ideally no carbon solutions. And in fact, we're developing in tandem with our reactor technology, thermal energy storage technology that will allow us to complement intermittent renewables. It's called grid reserve, and the way it works is, say you have a 300 megawatt reactor that's producing 300 megawatts of energy every hour of every day. Instead of constantly feeding this energy into the grid, it can be stored in large tanks and used to generate additional energy when the grid needs it most. So, you know, for example, when demand is peaking or when the sun isn't shining or the wind isn't blowing. And with grid reserve, a 300 megawatt reactor could generate 900 megawatts of energy for short periods of time, but it's enough to enable this 100% clean energy grid. There's a lot more to our reactor than just that, but those are the high level points. And so I'll leave it there. And on the next slide, you have my information. So if you have any questions, please feel free to reach out to me. Thank you.
Yes, good morning. That's Rob Harvey, Director of Energy Infrastructure for Hydrogenics and Cummings, and I'll be talking about both of those and talking about the transition. I appreciate the invitation from SIA and OCE to present today. I've been able to join and hear a number of the panelists. It's remarkable the amount of innovation that is going on in Ontario, some very exciting projects. And today I'd like to share a bit about what we've been working on in the last couple of years, and also talk about the story now that we're part of Cummings. Next slide, please. I'm sure you've all heard of Cummins as well. They're renowned for diesel engines and a company that's been around a century. And interestingly, they were the company that was the innovator back in the 1930s of introducing diesel engines to mainstream truck operators in North America. Spend nearly $1 billion on R&D. And as a company, Cummins provides a drivetrain of choice for our customers, whether it's diesel, a hybrid, natural gas, battery electric vehicles, and of course, fuel cell electric vehicles. Just over a year ago, they acquired Hydrogenics and have been working to integrate our fuel cell and electrolyzer technologies into their broader product line. I think one of the things that the characteristic of Hydrogenics in terms of our speed to market and bringing innovations to market, both on the fuel cell and electrolyzer side, is something that is very much appreciated by Cummins. And indeed, with the resources behind a very large company like Cummins, it's something we're able to move even faster than we were before. Next slide, please. If you look at our two core businesses, our fuel cell power modules and electrolyzers, we make fuel cells or fuel cell compositions for OEMs and integrators of buses. There's an example in China. For trains, commuter trains, I'll be talking more about the Karate Island. That's the first zero-emission fuel cell train in the world. And then a wide variety of truck platforms, including Class 6 delivery vans, as you see there, and Class 8, full Class 8 trucks. On the electrolyzer side of our business, which produces hydrogen, we've been very active in the emerging power to gas and renewable hydrogen space. Give you some project examples here. One of the very first projects in 2013 was with Uniper in Germany, a 2 megawatt power to gas plant. More closer to home, we've done a fueling station with Harnois in Quebec City and provided the electrolyzer for one of the very first fueling stations, hydrogen fueling stations in Canada, and our power to gas plant partnership with Enbridge in Ontario. Next slide, please. You think about what a lot of different component suppliers for a train like Alstom. If those of you from Ottawa may recognize that train and say, wait a minute, we've got that train. The diesel mobile unit of that train, the DMU version of that train, runs in under OC Transpose network in Ottawa today. And what Alstom did was develop a zero-emission fuel cell electric version of the same train. So the train on the outside looks the same. The performance is the same in terms of top speed, 140 kilometers an hour, in terms of having up to 300 passengers in the train, and the range, daily range, the fueling time is all comparable to a diesel vehicle. The part that we provide is on the bottom right there is the fuel cell composition, and it's made up of, it's rated at 200 kilowatts, that HD 200. It has our workhorse HD30 fuel cell power module as part of it, and also has the frame, the radiators you see on top there, the system, the fuel, air and water connections, and the master control system for that train. This train has been in service since September 2018, and Alstom is now filling orders from first mover municipalities in Germany. This is a very exciting development, and there's a lot of enthusiasm in Germany, Austria, and beyond. Next slide, please. On the electrolyzer side, we've been working for 20 years to develop PEM electrolysis. And even though we've got a very well-established product, pressurized alkaline in the industrial electrolyzer business for on-site generation, the PEM product is the platform that allows us to scale to the 20 megawatts, 50 megawatts, 100 megawatts and higher that's required for large renewable green hydrogen production. And this is some of the developments over time. In 2014, we did the first 1.5 megawatt cell stack. That's the highest power density in the world. We've done a dozen projects in Europe, and the first project that we did in North America was the 2.5 megawatt Markham energy storage facility. And last year, we completed, started the development of the 5 megawatt product platform, which is our first indoor product for very high capacity and a scalable solution. And I'll be talking a little bit about both of those in a moment. Next slide. This is the picture of the Markham Energy Storage Facility. This is a joint venture project between Enbridge and Hydrogenics. It's located in Markham at Enbridge's Technology and Operations Center. And that's the primary building. And you can see in the front there, some of the equipment is outside, like the switchgear and the chillers. Inside, that's a picture of the heart of the electrolyzer plant is the electrolyzer, two 1.25 megawatt stacks. This was the first indoor application of a project that we built, and the learnings from this have informed our next Hylizer 1000 product design. This plant has been running since May of 2018 and is under contract providing regulation services to the IESO. Next slide, please. This is a view of the Hylizer 1000 electrolyzer. Our product platform for delivering 1,000 normal meters cubed per hour. That's equivalent running all day of 2,000 kilograms a day, which is an awful lot of hydrogen. And I'll talk about our first project in a moment. You can see at the right there, the two electrolyzer stacks. Our next generation electrolyzer is 2.5 megawatts and has the key balance of stack components in terms of deionized water management, hydrogen management, the control systems as part of the solution. So we bundle this in skids, factory assembled, with a rectifier and with a supervisory control system. And it's combined with the balance of plant items, such as the water treatment plant, such as the chillers, by the EPC on site. And next slide, please. And our first project here is, this is a view of a scalable, a 20 megawatt plant, 8,000 kilograms a day. And to put that into perspective, 8,000 kilograms a day would be enough to fuel 265 transit buses every day. So we're talking, this is a significant scale production of hydrogen. You can see there's 4 lines of our Hylizer 1000, each with the skid and then the rectifiers at the top of the screen. And then the balance of plant components shown there in terms of the hydrogen dryer, the chillers, the supervisory control system, electrical panels, and so forth. We believe we've got a very compelling value proposition for this plant. It's the highest efficiency electrolyzer, highest power density, so it's got a low footprint. You can see that the core system fits in 500 square meters for 20 megawatts. It delivers 30 bar hydrogen output. A number of our competitors deliver plants with atmospheric 1 bar output. PEM electrolyzers got a very fast dynamic response. That's why it works so well with the ISO, providing regulation services, and there's no harmful chemicals for that. Next slide there. So there you have it, Hydrogenics powered by Cummins. So it's the same hydrogen technologies for a cleaner hydrogen future, and we're growing. You know, since January, we've hired 50 people at our Mississauga location, and we're still growing still. So Hydrogenics is now powered by Cummins. Our hydrogen vision is the same, and we're moving forward. Thank you.
Hi there, my name is Mike Kelland. I'm the CEO of Planetary Hydrogen, and at Planetary Hydrogen, we say that we make the greenest fuel on Earth. So how do we do that? Well, we start with hydrogen, and hydrogen has a really established market. It's about 50% split between oil refining right now and fertilizer production, but it's primed for massive growth, growing by double by 2030 and growing 7 to 10 times by 2050. And in the process, it's predicted to replace a lot of fossil fuels in various parts of our economy, everything from heavy transportation, as Rob was talking about, through to residential heat in the natural gas pipeline and energy storage. But in order to achieve that future, dirty hydrogen just won't cut it. In order to have it replace fossil fuels, it has to be cleaner than fossil fuels. And hydrogen coming from places like natural gas actually is dirtier in terms of carbon intensity than even diesel fuel is. The problem is that most hydrogen in the world today is actually very dirty. So only 5% of hydrogen worldwide is produced from electricity with things like electrolyzers from Hydrogenics. And that's because dirty hydrogen is super cheap. It runs about $1 per kilogram from hydrogen from natural gas, $1 to $1.50. And right now, depending on the price of power, between 5 and even more times that for the price of hydrogen from electricity. So our hydrogen actually reverses that trend. So we produce hydrogen that actually takes carbon dioxide out of the air as it's produced, thereby giving us a hydrogen that has a negative carbon intensity. That means that we can leverage current carbon credits around the world in order to produce a hydrogen that has a value or a cost to produce that is cost competitive or even less than the dirty hydrogen that's currently on the market. So how do we do that? Well, we take an electrolyzer and we add a special ingredient to it. That allows us to produce hydrogen and this stuff called hydroxide at the same time. We use the hydroxide to capture and store carbon directly from the air and transform that carbon dioxide into an antacid for the ocean. That then locks away that carbon dioxide in ocean chemistry for over 100,000 years. So this is actually our natural process. The Earth actually takes carbon dioxide out of the air and stores it in ocean chemistry through a process called the slow geochemical cycle. We really just speed that up using electricity, and as a byproduct, produce this hydrogen which has that negative carbon intensity. So what can we do with negative carbon intensity hydrogen? Well, the first place to look is utilities. And utilities need to use CCS in order to extend the lifetime of their fossil fuel fired assets. But the geology for capturing and storing that carbon dioxide isn't right everywhere. You can't bury it just anywhere you'd like. And so what we do is that we add the ocean as a sink for that carbon and accelerate the natural system's ability to store and capture that carbon safely in the ocean. At the same time, we're able to provide hydrogen for energy storage on the grid. But let's talk a little bit about fuels. Right now, fuels is the largest market for hydrogen. Over half the hydrogen market is used to refine fossil fuels. Negative emissions hydrogen can actually be used to radically reduce the carbon footprint of liquid fuels and natural gas, up to 50% for some forms of crude oil. But we can fly further. Imagine a world where we actually have every mile that you fly takes carbon out of the air. If we use a biological source of carbon, like a corn oil or a used waste oil, then we can use our negative emissions hydrogen to produce a negative emission aviation fuel or gasoline or diesel that actually takes carbon out of the air as you burn it and consume it. So where could this take us? We were founded as a company in 2019, so we're only a year old. And in that time, we've already started to build out our pilot plant and have achieved a commitment to purchase our carbon removals from Shopify. In the next few years, we plan to build out a pilot plant and get to a commercial plant by 2024. Our goal is that by 2030, we plan to be taking almost 10 million tons of CO2 out of the air per year, which would only be 0.16% of the hydrogen market at that point. But we have gigaton ambitions by 2035. I'm very happy to take any questions later on, and thanks very much for your time.
Hi, everyone. Kicking off this next cluster, my name is Toby. I work on financing clean energy projects with Vancity Community Investment Bank and CoPower. And I'm excited to introduce to you how we are able to provide financing for clean energy projects and impact solutions. Next slide, please. As VCIB, we are a bank on a mission to finance a sustainable tomorrow. We are a Schedule I bank with a national mandate and the only Canadian bank exclusively focused on partnering with organizations that drive social, economic, and environmental change. We were born from the values-based community-first model sharpened by over 70 years of experience at Vancity, a financial cooperative out of British Columbia with over 500,000 members. Next slide, please. VCIB acquired CoPower about a year ago, Canada's first sustainable investment platform and a leading provider of financing to clean energy and energy efficiency projects. Together, we will accelerate the investment in affordable and sustainable communities. Next slide, please. So combining our experience and expertise in providing solutions to underserved markets, VCIB and CoPower have come together to use the tools of finance to drive immediate and lasting change in our communities. And how does this look like in application? On the one side, we have social purpose real estate and where we prioritize financing for affordable housing and high-impact community projects, including co-working spaces, arts and cultural hubs, heritage buildings, and non-profit-owned facilities, and now also green buildings. We have financed over 400,000 square feet of nonprofit and cultural community spaces, as well as financed or preserved 1,300 new housing units, affordable housing units. On the clean energy side, we connect clean energy developers, installers, and building owners with the financing that they need to provide clean energy generation and energy efficiency projects. The general examples in this space include generation of renewable energy, such as solar PV, for example, energy efficiency installations and retrofits, as well as sustainable infrastructure, such as energy storage, for example. Next slide, please. So why do we do this? We have two primary markets that we address that are fundamentally underserved by traditional financing mechanisms. On the one side, we are looking at the clean energy market, where over 30% of Canada's emissions come from our built environment. But the development of clean energy projects, especially for smaller distributed clean energy projects, is still having a significant difficulty getting off the ground, and already established technologies and projects that have proven themselves in the market are still starting to receive financing, especially in the small to mid-sized scale. On the other side, there is a proven demand from the investor base, especially for small investors who would like to be participating in the sustainable and impact investing movement, but have been unable to do so because of market barriers such as high investment minimums or simply a lack of availability of products in the market. Next slide, please. So our approach to this has been to provide financing solutions to this particular market in the small to medium-sized clean energy and energy efficiency space, at CoPower specifically, and now recently was VCIB. As an example, we have financed a number of residential geo-exchange projects in British Columbia, Ontario-based community solar. We have done a 500 household retrofit for microfit projects here in Ontario and Toronto region, a project of residential geo-exchange in Toronto, as well as a couple hundred LED retrofit in buildings, commercial buildings and condo buildings across Alberta, British Columbia, and Ontario. Next slide, please. We have a nimble approach to financing and work with partners to find mutually beneficial financing solutions. And I understand that the presentation is being shared after this session, so I won't go through every single piece of detail here. But in general, we look for projects that use well-established clean energy and energy efficiency technologies that have credit risk that is moderate and mitigated, and projects that are secured by, and loans that are secured by project cash flows and the underlying material contracts. Next slide, please. So when structuring transactions, we specialize in the space for loan sizes between 500,000 to 20 million, although we may also consider a larger ticket size for a single project or a portfolio of smaller projects. We typically lend between 60 to 80% of the project costs, although there's also experience that we've had, and it is possible some structures allow to provide 100% of financing. We see competitive pricing terms and rates, traditionally between 2 and 12 years, as well as with amortizations of up to 25 years in operating projects, or they could be as short as 3 to 6 months in the case of construction-based projects. This is a pretty quick introduction to our loan process, but if you have any questions or if you have any doubts or are unsure whether a project that you're considering might fit these criteria, certainly feel free to get in touch and we'll be happy to chat to you in person and in more detail. Next slide, please. Finally, an exciting product that has come from the joining of VCIB and CoPower in the real estate and the clean energy space has been the commercial green mortgage that VCIB offers. So for building owners, VCIB offers increases to commercial mortgages to finance as well the energy efficiency upgrades and retrofitting of properties, or for borrowers that already have a commercial mortgage in place. We offer a non-revolving term loan to finance energy efficiency upgrades and retrofits that can enable energy efficiency savings of 30% or more while reducing GHG emissions. Last slide, please. And that brings me to the end of our presentation. Please feel free to reach out to us about your project financing needs, or if you have any questions to learn more, and we'll be happy to chat. You can gladly connect with my colleague, Jonathan Frank, whose contact information is here below and will be shared later on, or with myself via LinkedIn, and we'll be happy to be in touch. Thanks again, OSEA and OCE for having us this morning, and to all the other wonderful presenters. It's been wonderful, and good luck. Have a good rest of your day.
Good afternoon, everyone. I know it's almost lunchtime, but what's a good way to get to lunch without an appetizer? So let's have some money talk, and then you can get back to your lunch. So next slide, please. I want to start by telling you a little bit about who we are, and more importantly, who we are not. We are not a bank. We are not a lending institution. We don't provide loans. But who we are is an investment solutions provider. So we go to buildings, we own the equipment, we take equity risk, and get paid based on performance. That's who we are. I'm sure a lot of you here know the Atmospheric Fund, TAF. TAF incubated us as an organization a few years ago. And prior to that, they used to do a lot of these projects themselves. Between us, we have a project track record since about 2012. That's about 8-9 years of project track record. And recently, we got into a couple of partnerships with Toronto Foundation and McConnell Foundations. Some of them have made an investment in us, and some of them are enabling us to get into certain other segments of the market. Next slide. So we have a bunch of solutions, and one of our main solution is ESPA. ESPA stands for Energy Savings Performance Agreement. And as many of you out here know, the reasons why a lot of buildings don't do a lot of the energy efficiency upgrades is because of multiple risks. But there are 3 major barriers which we talk about. One is capital. One is the availability of it, or the allocation aspect of it. The second one is risk. When I say risk, I'm talking about the fact that efficiency as an asset class rarely gets measured. So people do not know if it's actually performing or not. So the risk aspect is the second aspect. And the third aspect is capacity. Most buildings just don't have the capacity to do these upgrades because most of the people are voluntary, or the property manager is almost fully used up with the regular routine work. So the solution we provide works as follows. So let's say there is a building out there which is spending $100,000 in energy cost. We know that with a bunch of equipment upgrades, we can bring down the cost to say $70,000. But to save the $30,000 a month, maybe there is $1 million upgrade, $1 million investment needed, and which most buildings are not ready to do. So what we do is we go and put the $1 million down, zero contribution from the client. We own the equipment and give it to the building to use. So when we achieve the savings, and we only get paid when we achieve the savings, but when we achieve the savings of, let's say, $30,000, we get paid a share of it, say 20 or 25, which we pre-agree upon with the buildings. So right from day one, the building has reduced their energy cost to say $90,000 from 100, and they got a new set of equipment, which we then transfer to the building for free once the contract is over. As you can see, we have a track record of this particular solution in over 50 buildings, and all of them have been working fine. Next slide. We also have a couple of other alternate solutions. One is e-funded. All buildings, as you know, keep buying equipment. Let's say there is a $50,000 upgrade of a lighting system or a $100,000 boiler, which was put in last year. And today, no one realized that this pandemic was coming. Obviously, the operating conditions have changed. and the buildings want to use the money for something else. So what we do is we get in and buy this boiler or buy this lighting, and then we give it to them for use for a monthly performance fee. How it works is basically not only have we bought the equipment, but we are also now maintaining the equipment and managing this equipment, and we agree on certain performance parameters. So that's the methodology with which we work. That's eFunder. And efficiency as a service is something very similar to SaaS. It's taking the service concept to the next level. Software as a service is obviously well known, but let's take a case of lighting as a service, right? People are out there wanting light. They need to basically have light to read. They are not interested in owning the bulb. They are not interested in owning the fixtures. In efficiency as a service concept, what we do is we will basically go and provide the building lighting needed. So a shopping mall or a commercial building or a residential building, we will basically say that we will own the lights, we will own the fixtures, we will sell you lumens. So you pay me for every certain cents for every lumen we give you. Okay, so that's this thing, taking performance to the ultimate level. We take care of all maintenance and equipment failures, all of those. Next slide. So one of the common things about all the things we do is that we do everything with zero upfront capital by the client. And I'm not talking about loans, I'm talking about equity. So even the 20% equity, which many people have to put in when they borrow 80% from the bank or whatever it is, we take care of all of those equity. We do a complete turnkey solution. So there is hardly any pain in terms of the amount of time involvement. Obviously, we get it verified. Before we install any solution, the building has a say in it and agrees to it. And because we are not affiliated to any specific product or equipment vendor, we are agnostic. We choose the best solution for the given situation. We only get paid from savings. So effectively, there's a natural guarantee of savings built in. And on top of it, we know that one of the challenges of efficiency in the past has basically been people get into long-term contracts, opaque contracts, and then something changes. So even if you're into a 10-year contract, we give the buildings the buyback option. So in 6 months, they want to basically come and buy out their equipment because something has changed. We give them the option. It's clearly written into our contract. Next slide. Couple of recent projects we did. One is a project we are currently executing. This is a large social housing provider in Toronto. This is a complex of 8 buildings. We are upgrading $3.5 million with about 250 tons of carbon savings per year. So over the next 20 years or some such thing, it's about 5,000 tons achieved. Last year, we also did a multi-residential project for about $600,000. Both of these are multi-measures. We upgrade water. We take care of water savings. We do electricity. We do gas. So it's a combination of various measures. Next slide. So our approach, clearly our approach is very partnership driven. As owners of equipment inside a building, our interests are aligned with that of our clients. So we get paid when the client gets paid. So typically, it's a very clearly defined partnership approach for us, be it with a building owner or with a property manager. With the vendors, the way we work with is basically, let's say there's a controls company which has got a $100,000 controls solution which they want to sell, but most buildings are not able to buy it because they don't have a budget for it. So we would buy the equipment and give it to the building for a performance fee. This is the as a service concept. Engineers and ESCOs, we work with them because we are not a technical solution. We are project developers and project managers, but all the technical work and installation work is typically done by the engineers and ESCOs. And besides that, we also work with a lot of industry associations, governments, and other partners to basically further our solution. Typically, we make an investment of $500,000 and above per project. And we don't really have a maximum. Next slide. That's my contact info. If at all we need to basically need to reach us, you have the contact details there.
Thank you very much, Chandra. And I know Dan and I are going to be providing some closing remarks. I'd like to thank all the presenters, great speakers today, and quite an array of innovation and innovative solutions and technologies that are really reflecting the amazing work that's being done in Ontario in the sustainable energy sector. So on behalf of OCE and our team here, thank you all for your presentations and for your time today. And thank you, Dan, to you and the OCEA team. And I'll turn it over to you, Dan. Thank you.
Thanks, Belinda. I thought the presentations were excellent today. And I really wanted to extend my appreciation to all the presenters, as you have done, as well as the OCE team. And I think you'll all agree that the breadth of the ecosystem here in sustainable energy technology, helped along by OCE and others, is just fantastic. So thank you once again for participating and for viewing the Green Energy Doors Open 2020 campaign. Thank you and have a great day.